Yes. So we'll be doing end-to-end data analysis using Python basics, NumPy, Matplotlib, Seaborn, and Pandas, running locally on our system. So to start with, first of all, you need to install Python. So you can Google search install Python, go to this Python page and download Python onto your system. And then I am using something called VS Code, which is like the co-editor. So if you have to write applications, you go to a Word document. If you want to work with tables, you go to Excel sheet, right? Similarly, if you have to write code, you go to an IDE or integrated development environment. The very popular one is VS Code. It is free to use and comes with a lot of features for us. So I have I just installed VS Code. I went to this VS Code website, selected my exe and downloaded it, right? Once it is downloaded, then this is what my project looks like. Let me show in Explorer. So these are the project files for me. Virtual environment is something I have created, which is not required for you people now, but later on it's a good practice. It is like creating a virtual development environment for your project, so that you install specific libraries and packages to that specific environment, not to the your laptop general Python, right? Then we have this CSV file. Let me open this one. This is the student well-being data. Basically, I would say 36 students in a class, and what is their gender, what course are they studying, and yes, what course are they studying, how much time they spend on social media, and how much time they spend on studying, how much time they sleep, and what is their self-reported stress level, right? And what is their academic score, say marks, percentages. With this, we would like to analyze, like basically go through. You see, there are some missing values over here. Some values are missing over here, and this value is also missing. So it's an example data set, and we have to run this through all the Python libraries that we have learned. Okay, and we'll also make some visualizations, fill this data up, and try to see if there are any trends here. Okay, like in this table right now, we cannot say much. So the same thing I have opened in Google Colab. I basically go to this folder, open in terminal, and then you write code space dot. It will open this folder in Visual Studio Code, or you can just go to here, open folder, and choose that folder directly, the root folder, hands on, and I'll just use this folder, select folder, it will open the same thing. So the idea is all the files should be here, right? So now let us start. First of all, we would like to start with importing all the libraries. But since when you install Python for the very first time, all these libraries will not be there. So we have a file called requirements.txt. It's a standard way of doing things in Python, where you keep a note of all the libraries that you are using, probably with a specific code version also, but for now it is okay. So what you can do is just open your terminal, or just the terminal that you see over here, and do pip install and write all the names, numpy space pandas space matplotlib, and press enter. It will start installing like this, you see on the screen. So it will start installing. Yes, and it is already installed, right? It says requirements already satisfied. For you, it will install everything, probably take 2-3 minutes. Okay, once that is done, this is the actual notebook that we'll be working on. So now that as we have seen in all the classes, we have to import all the libraries first. So we'll be working with pandas, we'll be working with numpy, we'll be working with matplotlib, we'll be working with seaborn. So we're installing all of that, and we are setting a color theme. So the style is white grid and the palette is muted, right? And we are starting. Let me run this one. It should say library successfully imported. We are ready to begin. Yes, it says that. Now we would like to load our data. This is something we have not explicitly seen, but it's very simple. Just do pandas pd.read CSV, because we have a CSV file. It could be read Excel or read txt, whatever, and you pass the file name or the complete path if the file is in separate folder, right? Then you read the file and you present the display.head, df.head, basically to see the first 5 lines. in of the data set. This we have already seen. And then you print df.info. That is the very first step. I have loaded my data set. This is what my data set looks like. It's just like the Excel sheet, just the top 5 rows, because I am doing df.head over here. Let me get bigger so that it's easier to see. And I've also printed, this is not required, the summary of my data set. So what are my columns? What are the non-null values? What is the data type? This we have seen, right? So basically I see there are like 33 non-null values and there are 34. So there are some values missing over here. Okay. And how many entries are there? 35 entries are there. And this is a data type. This is what my data looks like. Okay. So now I want to clean my data. Why? Because in sociological surveys, people sometimes skip questions, or when we try to run mathematical operations, we get this error, null or NaN. So any multiplication division will not work if we are doing anything. So better we clean our data. How do we clean our data? First of all, we figure out, we print what are the missing values. df.isNull.sum. So it will print column wise how many values are missing as a sum of that. And then this we have already seen. df dot, first of all, let me run this cell for you. So I see there are, say, these 3 columns have missing values. Daily social media hours, daily study hours, and stress level. Someone has forgotten to fill this up. So how can we fix that? We can choose this column and replace this column, use this feature called fill NA, and use the median value, right? For study hours. You can use average, whatever feels good you can use. And we also have to do in place is equal to true. We have seen this in individual cells before, like in the class sessions, and now we are doing it at a project level, right? Same, the next line is this, and I'm replacing this with fill NA and using the median value and doing in place is equal to true. And we are dropping this subset stress level 1 to 10. We thought let's drop this column. There was just one value, so I'm dropping this, and now finally when I print this, I'm getting this. So before, this was my condition, I had some missing values. After, there are no missing values. There is some warning about this method of drop NA in place. That is okay for now. Okay. So now once we have dealt with the missing values, some of them we have replaced with the median value, some of them we have dropped. So let's now go forward and visualize how our data looks like. Okay. So we are doing univariate analysis, basically just looking at one parameter right now. And let's do a normal bar plot or a histogram of the stress levels. So how do we plot? First of all, we define a figure size. Suppose I want to see it on a big scale. Then I'm plotting a histogram. And of which column I want to plot? Stress level. Bin size is this. KD is that curved squiggly line. And color is salmon. And labels I have provided. That's all. When I run this is what the stress level is. So first of all, it looks like there are 2 peaks over here. So there are a lot of students who fall in this area where they say they have a average level of 4, right? 5 students say that they have average level of 4 as their stress. And there is another group which is on the right hand side, which says that around 6 people say that their average stress level is around 8, right? That's why we see 2 peaks in this plot. You can change the number of KD bins, KD bins to be, let's take 20, and then run this one. Now you will see a plot like this. Okay. Because everybody has put values from 1 to 10 and it's a number only. So let's keep it at 10 only. This is what my stress level looks like. It's a univariate analysis because we are just looking at one parameter, one column only. Then let's do some sort of feature engineering. Suppose what if I currently have my data set only have this numbers, daily sleep hours. What if I want to see good sleep, bad sleep, or normal sleep based on some threshold, right? So I want to create a function categorize sleep. If your sleeping hours is less than 6.5, I will call that student sleep deprived. And else, if it is more than 6.5, I'll call it adequately rested, right? And I'm adding a new column in my data frame, which is apply the categorize sleep function on the sleep hours column and fill it up. So now if you see, adequately rested at 18 and sleep deprived at 16. So basically half of the class is not sleeping well, half of the class is sleeping well. We'll have to figure out do some analysis. Okay, now we are doing bivariate analysis, basically looking at two columns together, right? So figure size I'm defining, then I'm creating a reg plot. We have seen that it will plot a line along with the dots. Whatever I'm plotting, it's daily social media hours versus the academic score. So we are trying to understand the time you spend on social media and how do you score on your exams. This is normal. I'm just X level, Y level, that's it. So when I plot this, this is what I'm getting. This data is actually handcrafted. So it could mean something in the actual world or may not mean. Just for our learning, we are doing it. Okay. So it seems that on the x-axis we have daily social media usage. So more number of hours you spend on your phone, and on the y axis we have academic score, your marks. So you see that if you spend more number of hours on social media on your phone, you are scoring less as per this data set. This is what the school administration found out, supposedly, right? So it's a clear trend. Just by looking at this particular plot, we cannot show any trend. Okay, we have to look at, okay, 88, he slept for 7 hours, and he was spending 2.5 hours on social media, right? We cannot say anything from here. But when you create a diagram or a plot out of the same data, you have some sort of a trend. Okay, now let's do some sort of a group comparison. So I'm creating a box plot based on the course they are taking and their stress level, right? And let me print this, run this cell. It's just like a Jupyter notebook. So this is what I get. Sociology student has the most variation, not the most, like I would say the lowest stress somehow. Computer science has more stress. So even psychology is kind of chill only, and engineering students have the most stress because we are trying to plot it by major, right? So x-axis is the course they are taking, y-axis is the stress they have plotted. Okay. And this is their average distribution. Just again, it is a handcrafted data. It need not be true. But when you do a research or when you do a survey, then it will tell the actual information. Suppose you go in your campus, put out a WhatsApp form. Okay, please fill out this form. I want to understand how much stress are you. Then you can do this sort of replication, this sort of plotting. Right. Now let's do another plot on the same data set. Same. I want to plot a Boolean plot. On x-axis should be my major, which is basically the courses you are taking, the degree program you are in, and the stress level, right? And let us print this one. Say rest is just what is the title, X level, Y level. So this will give you a shape, right? The exact distribution of stress of all these students, right? Or you can try out with different plots as well, or you can try out with different parameters of the plot to figure out something else. Like here we can see engineering students, I would say the number is less, but they feel the most stressed, right? So if I want to have a count of the students, that also we can do, right? So we also get an exact distribution in this way. So they are somewhere around 8 point something, the stress levels. And actually computer science go from 0 to 100. So there are people in computer science who have no stress at all. And there are someone who is having a stress level of 12 also, right? So now let's do a group by, or say try to study things in group. Say I want to study how based on the program they are teaching, they're taking, and the stress, what is the difference between gender, like how each gender is handling the stress separately. This is all same, right? Tight layout will fit everything together. And we are doing a bar plot. This, everything you have seen in the classes. So if I print this, this is what it is telling me. So we have male, female, and non-binary, the gender. And what I can actually figure out is, in all the courses, the non-binary people are facing a lot of stress, right? Maybe it is a handcrafted data, but this tells me, because in sociology also this is the highest, computer science this color which is of non-binary is the highest, except in psychology they are doing pretty well, it's the lowest, and in engineering it is the highest. Okay, so basically what I can understand from this plot is that there is something that the psychology students who are non-binary have understood something or manage their stress better than the other streams, right? So, and what about males? So male in engineering have less stress as compared to females. in psychology, males have more stress as compared to all the other genders, and in computer science, it is like more than females, right? Green are the females. And if you look at general trend, yeah, this is how you can understand based on the different gender for each program, degree program, what kind of stress the each gender is facing. So this was our unique finding, right? Just by looking at the data, no analysis. Right, let's look at some sort of other analysis. We did this pair plot, right? Pair plot where we get all the columns plotted with each other, and we can select the diagram what you want, corner is true or not, right? Alpha value is for, you have plot KWS, which is basically what kind of transparency you want, font size, all of that, right? And I want to plot, I have created a new data frame because pair plot only works for numerical data. So I have just picked from my data frame only the columns which have numbers, these 5 columns, that's it. And when you plot this one, this is what it looks like. I think I could reduce the size. Yeah. So this is like each column when plotted with each other. Okay. So wherever you see this KD plot or this normal diagram is the column with itself, which is basically daily social media hours is this plot. And if you want, you can study daily study hours with respect to daily social media hours. So if your social media hours are more, your study is going to be less because you have same number of hours, right? So let me just zoom in this one. So basically this plot, your x-axis is your daily social media hours, y-axis is daily study hours. So if you go towards the right, your hours will come down. If you go towards the left, your study hours will increase. This is the general trend also. Okay. Now, like this, we can study different columns with each other. I can totally see some patterns. Sleep hours are more, then your academic score is also more. This just plotting this data tells me that if you sleep for more hours, by default you will get good marks, and that also connects with your biology or psychology, right? If you're well rested, slept well, you can answer better. Your brain works better. And stress level is if you plot academic score with stress level. So now we are trying to understand what could be the reasons for the stress. Either it is like spending more time on social media, not getting enough sleep, or poor performance in academics, right? It could be anything. We can analyze any column. So as per this, if you have high stress, your academic score is less, or your academic score is less, that's why your stress is higher. You cannot say both, right? But it has to be something. So now what if you want to have some sort of analysis where we want to have a heat map of some sort of correlation between these two things. Correlation is if one thing is growing, other thing is growing or not growing or going in the opposite direction, right? Suppose if you have more height, you will have more weight. If you study for longer hours, you'll have more marks, ideally, right? So this is the meaning of correlation, how two things are correlated, right? If it rains, less number of people will come. So negative correlation. Number of attendance and rain has negative correlation. More rain, less attendance, right? So similarly, you can have a heat map where you can create a heat map of all the numerical columns, convert them to a correlation matrix, and then do a heat map like we did for the flight, number of people traveling each month. Okay, so this is your correlation heat map looks like. So let me just zoom out a bit. Yes. So basically social media hours with respect to social media hours. So your diagonal will always be 1 because you are fully correlated with yourself. Okay. Now I want to look at daily study hours with respect to daily social media hours. I see a correlation of minus 0.63, negative correlation. The more I study, the less social media I will do. The more social media, the more time I spend on social media, less I will study. So negative impact, but it is significant. 63% correlation, or 63 is the correlation. Then let's look at this number. Stress level 1 to 10, sleep hours. So if your sleep hour are less, so it's like highly correlated. If you sleep very less, your marks are going to be Your stress, sorry, not marks. There's stress. You sleep less, your stress will be more. You sleep more, stress will be less. It's a very high correlation, 0.95. And this is your legend. So bluer the number, the negative is the correlation. The orange the number, the higher is the correlation. Let's look at any other thing, say this point. Daily social media hours with respect to academic score. So more number of social media hours means less academic score as per this data set. So without performing any sort of analysis, this is the last cell, we are done. So without performing any sort of data analysis, actually just by visualizing data using Python, we can see lot of trends. If you spend more number of hours on social media, you are going to score less marks. I am not saying this is what data is telling me, and data is coming in from some actual trustable source, right? If you study for more hours, there is a positive correlation. If you study for more hours, you will sleep hours are by default more. So if you're studying for more hours, you are by default sleeping for more hours. And that is somehow related to biology as well, because when you're studying for longer hours, you are using your brain to your maximum capacity. And when your brain is tired, you will by default sleep more peacefully. That's why after a hectic day of work, you sleep like a baby. Okay. So this is also coming up over here. Or if you want to look at stress, let's look at sleep hours with respect to daily social media hours. Sleep hours, if it is negatively correlated. If you are not sleeping for very less time, that means you are spending more time on social media, or vice versa. If you spend more time on social media, you get less time to sleep or bad sleep, or you say you're using your phone on the night, you're not able to sleep early and you have to wake up early anyway for the next day's college, right? So this is what we can understand end to end using whatever we have learned so far. We can make different visualizations. We can have these correlations, have these plots to make sense of data, right? So I will be sharing all of this. You try to go through it and tell me your findings.